Hello, I'm Chris Augustine. I'm a nutrient management specialist at the Carrington Research Extension Center. My contact information is at the bottom of this slide. Containment ponds are constructed at the base of a feedlot slope and designed to collect and contain nutrient-loaded runoff. Ponds are designed to hold water for at least 270 days plus the 24-hour, 25-year rain event with an additional foot of freeboard. Containment pond effluent levels are designed to be reduced through evaporation. However, during wet years, precipitation can be greater than evaporation. This leads to a situation where pond drawdown is required before there's an overflow. Monitoring pond levels and land applying effluent before a pond is full prevents overfilling of the containment pond. Irrigation systems like a traveling gun or a movable sprinkler system work well to apply containment pond effluent. Containment pond management needs to be a proactive management practice and done before an issue has a chance to arise. A full containment pond may discharge its water, causing pollution to a downslope water body. A discharge event may erode away pond banks and require extensive and expensive dirt work to fix. It is important to routinely check the containment pond, water diversions, and other earthen structures for structural soundness and any signs of erosional damage or seepage. The best time to manage a containment pond is during the summer. This is when evaporation is greatest and soils tend to be the driest. However, high pond levels are most likely to occur during or shortly after the spring snow thaw. Finding a suitable application site during the spring can be difficult. Saturated soils are common and this can increase runoff risks. If effluent needs to be applied during the spring on wet soils, the effluent should be applied as thin as possible and on as many acres as possible. If a discharge occurs, you must notify the North Dakota Department of Health within 24 hours of the discharge. Their phone number is 701-328-5228. For more information on containment pond discharges and management, consult the NDSU Extension publication, Manure Spills, What You Need to Know, and Environmental Consequences, NM-1555. Besides checking the structural integrity of earthen structures, containment pond levels need to be recorded. Here are two examples of different pond markers. The one on the left uses cattle tags for monitoring. The one on the right uses different stripes for monitoring pond levels. For more information on containment pond depth markers, consult NDSU Extension Service publication, Liquid Level or Depth Markers for Earthen Runoff Ponds, NM-1514. Applying pond effluent on soil is more than spraying water on land. Soil infiltration rate and crop nutrient requirements need to be considered when land applying containment pond effluent. Here's an example of a traveling gun applying containment pond effluent and the reel that pulls it across the field. This is a high flow pump powered by a PTO. The gun is programmable to apply effluent at certain levels. Once the gun is back at the reel and gun are moved down the field and is set again to spread. Here is a low flow irrigation system. The low flow requires a 10 horsepower or so motor to pump the effluent. There are sprinklers inside the pod. This is periodically pulled across a field with an ATV once an area has become saturated. Soil infiltration rate is predominantly determined by topography, soil texture, and soil water content. Slopes affect soil infiltration rates because of runoff. Steep slopes increase runoff, whereas shallow slopes have less runoff. Depressional areas create ponding and allow more time for water infiltration. It is recommended to apply pond effluent on slopes less than 6%. Caution needs to be taken when applying containment pond effluent near surface waters. Effluent cannot be applied closer than 100 feet to down gradient surface waters open tile line intake structures, or wellheads. Barren soil fields are prone to runoff and erosion. Effluent should be applied on fields with vegetation or residue. Applying effluent on areas where buffer strips, standing crops, and forage are present greatly reduces the chance for runoff and erosion. Finer textured soils such as clay will infiltrate more slowly than coarsely textured soils. A clay's water infiltration rate is approximately 0.02 inches per hour. Sand's water infiltration rate is much more and is approximately 8.27 inches of water per hour. Water infiltration is fast on dry soil but slows as it saturates. Soil texture also predominantly determines the amount of water a soil can hold. Even though water infiltrates faster into a sandy soil than a clayey soil, the sandy soil will hold less water than the clayey soil. Sands can hold up to 1.1 inches of water per foot of soil. Clays can hold about twice as much water. This is because there is more pore space in the clayey soil than the sandy soil. The effluent must be applied to meet crop nutrient needs. Small amounts of nutrients can be found in containment pond effluent. Testing effluent for nutrients is important to ensure that application rates do not over-apply nutrients. Excess nitrogen and phosphorus in surface water can cause algae blooms and lower water quality. However, excess potassium in surface water does not lead to algae blooms. Keep in mind while pumping that you pull water from the middle of the pond. This will prevent pump plugging from sediment entering the pump and reduce wear and tear on the containment structure. Be sure to check the hoses, attachments, and pumps for leaks. Proper containment pond management is an important piece in a nutrient management plan. Utilizing effluent water as an irrigation source is a good use while lowering containment pond levels. Apply the containment pond effluent before there is a problem. Caution needs to be taken to not apply effluent greater than a soil's infiltration rate and in areas that are prone to runoff. Apply pond effluent at agronomic rates. Keep records of pond levels and application practices.